DLR's ATRA Airbus is heading out to perform an ambitious experiment. A Vision is set to take wing. Flying will be even more important than it is today. More than 20,000 commercial aircraft already take off and land daily, and that figure is expected to increase. At one of the world's most important events for aviation, the Paris Air Show at Le Bourget, DLR exhibited ATRA and introduced the SANDRA project to the public. Many visitors to the event were enthusiastic about the concepts and ideas demonstrated for implementing aeronautical communications in future. On this flight, DLR's largest research aircraft is testing technologies that are still a vision. During flight, pilots are mainly cut off from routine digital communications. DLR's Institute of Communications and Navigation is aiming to change this for the first time. Air traffic communications are still analog, using technologies dating back to the last century. Air traffic controllers in the tower use analog voice communication to speak to pilots. Even when the greatest care is taken, this remains a source for potential errors. Communications possibilities reach their limits here. The SANDRA project's vision is the complete networking of all aeronautical communications systems. Global, digital, reliable and safe. It will be based on these pillars: applications and services, networks, radio transmissions and satellite links. Whether they're in the cockpit or cabin, SANDRA will support all applications, including air traffic control, airline communication, and passenger communication. The experiment is facing up to this challenge in flight. Developed by DLR and its industry and research partners, the SANDRA system aims to enable reliable, safe and automatic data transmission to the ground via satellite. Researchers want to know if this is possible in principle. The aircraft segment is made up of an integrated network, software-defined radio, and the antennas used. Pilot voice communication, surfing on the internet, and other data transmissions are now all digital. Dependent on the applications, regulatory standards, and available broadcast possibilities, the SANDRA system also automatically chooses the best means of transmission, terrestrial or satellite. The information sent from ATRA is received on the ground. The data independently find their way through the network, no matter where the aircraft is located at that moment. If one connection fails, an alternative is automatically detected. There are 3 transmission possibilities. 2 possibilities already available are terrestrial VDL2 and BGAN-based satellite data links. A third transmission possibility, which applies a high data rate airport communication system, namely Aeromax, has been built and tested and shown to be a candidate for integration in future. The ground segment receives all applied radio links. Internet technologies based on IPv6 allow data from different applications to be made available and distributed to all airspace users worldwide, giving each of them an overview of the current situation simultaneously. The technical implementation of SANDRA is made up of many different components provided by all the partners involved in the project. The integrated network makes possible the inclusion of all applications and services based on the Internet standard IPv6. Voice communication with the ground is now fully digital. The interplay between modular software-defined radio and the integrated network provides seamless handovers from all data links. This allows flexible control of all radio transmission components. The built-in terrestrial data links Aeromax and VDL2 are operated by radio broadcasting components that were specially developed for the system. A new antenna had to be installed on the research aircraft for the Aeromax of the future. The BGAN satellite service was used to transmit the experimental satellite broadcasts. SANDRA's built-in redundancies increased the safety of the system. The in-flight experiment has reached its peak. Integrated digital aviation communication is possible. The SANDRA project has now demonstrated this successfully. Earlier limits to communications on board aircraft have been surmounted. Digitally networked flight is clear to take off.